Hi, I'm Paul Kyogan from GK Tuition, and in this video I want to talk to you about financial maths. Now the question we're going through here is 2017 Paper 1 Question 8 Part 8. In this question we're told that a loan of €P is taken out and that the value of each repayment is €A and that the number of repayments is T and the interest rate is I. We're asked to use the sum of a geometric series in order to prove this formula. Now you should notice that the formula they've given you is the amortization formula. This can be found on page 31 in your log tables. So I've been asked to use the sum of a geometric series in order to prove this. Well, clearly then the first thing I need to do is actually come up with a geometric series. So I'm going to come up with a geometric series, then use the formula for the sum of a geometric series in order to prove this. If I am paying money back, then in order to come up with a geometric series, I sub into this. So you'll notice this is the second formula on page 30 in your log tables. The present value is equal to the future value over 1 plus I to the power of t. We use this formula if we're paying money back, or if we're paying back a loan. So in this scenario, my very first repayment is going to be €1. Okay? And that's my future value. So in the future, in a week, or in a year, or in a month, I'm going to pay €1. So that's the future value. And I'm going to divide that by 1 plus I, where my I actually just stays as I because my interest rate is just represented by an I. Now this is the first repayment. So the first repayment, it's to the power of t, which represents the repayment number. And in this case, this is the first repayment, so it's to the power of 1. So my very first repayment is the amount of the repayment divided by 1 plus I to the power of the repayment number. So that's my first term in my geometric series. And now I can just continue that to get my second term. So the value of each repayment is the same, so it's still going to be just A. The interest rate is the same, so it's 1 plus I, except this one is to the power of 2, because it's my second repayment. Now the next one, it would be the exact same, except this would be a 3. The next one I'd have to the power of 4, the next one to the power of 5, to the power of 6, and so on. But obviously I don't want to write out a whole bunch of fractions. There could be 100 repayments. So I don't want to write out 100 different fractions. So I just do ... to indicate that there's a number of terms in the middle. So other than the first two, the only other one we need to write is the very last repayment. The last repayment will have a value of A, the interest rate will stay the exact same, and it will be, well, I know the number of repayments is T. So the last repayment will be the tth repayment, or it'll be to the power of t. So I know all of this represents all of the repayments of the loan. And when I add up all of my repayments, they have to add up to the value of the original loan, which I know that the value of the original loan was €P. So all of these repayments will add up to P. So at this point now, I've written out my geometric series. Now I need to use the formula for the sum of a geometric series, and then I can manipulate it to do this. So to be honest, from here on out, this is actually a sequences and series question. So if you go to sequences and series in your log tables, the formula for the sum of a geometric series is Sn is equal to A times 1 minus or to the power of n over 1 minus or, where Sn represents the total value of the geometric series, which in this case I know that all the repayments added together must add up to P. So I know my Sn is P. In a geometric series, A represents the first term. So now just make sure you don't get mixed up between small a and capital A in this case. So my small a represents the first term in my geometric series. The first term in my geometric series is capital A over 1 plus I. So my first term is A over 1 plus I to the power of 1. And or represents my common ratio. Now in a geometric series, to come up with your common ratio, it's any term divided by the previous term. So in this case, if I divide the second term divided by the first term, now I'm going to skip the lines here, but if you divided the second term divided by the first term, you would just get 1 over 1 plus I. So my common ratio is just 1 over 1 plus I. And then n represents the number of repayments, or the number of terms, which in this case, I know the number of repayments or the number of terms is just t. So in this case, instead of an n, I'm going to sub in a t. So let's just sub straight into our formula here. Instead of Sn, I can sub in P. Instead of small a, I can sub in capital A over 1 plus I, times 1 minus or to the power of n, where my or is 1 over 1 plus I, and my n is t, so it's to the power of t. And that's all divided by 1 minus or, which in this case is 1 minus 1 over 1 plus I. So now let's just look at what we have. I've one equation, and the only unknowns in my equation are capital P, capital A, small I, and a small t. Now let's look at what we're trying to prove. I've got one equation, my only unknowns are capital A, capital P, a small I, and a small t. So now I have the correct unknowns, I just need to manipulate this around so that it looks like this. So from here on out, we are actually just dealing with algebra. We just have to manipulate the rest of this. So if you want to pause the video and just take that down, let's start with our manipulation. Okay, so as you can see, I've already started this one. So where we have now, we subbed into our sum of a geometric series, we have this. Now unfortunately there's a lot of fractions here, so I think the easiest way to do this, the first thing I would do is I just take the top line. So if we just take the top of our fraction and try and simplify it. Well, you'll notice here that I've rewritten this as a over 1 plus I times 1 minus 1 over 1 plus I to the power of t. Now notice here I have 1 over 1 plus I to the power of t, where the whole thing is to the power of t. And I've rewritten that where the 1 is on its own and the bottom is 1 plus I to the power of t. That's the same thing, because all this means is it's 1 to the power of t and it's 1 plus I to the power of t. Well, 1 to the power of anything is just 1. So I could rewrite this as just 1, so the top line is just 1, the bottom is 1 plus I to the power of t. All I've done with the top line here is that in the fraction, just within the fraction, we get a common denominator. So I would treat this first term as 1 over 1. And whenever we're subtracting fractions, if we have two fractions and we're trying to subtract them, we get a common denominator. So our common denominator in this case is 1 plus I to the power of t. And our numerator becomes 1 plus I to the power of t minus 1. And for the moment, that's all we're going to do at the top. Now, if we look to the bottom of it, the bottom I have 1 minus 1 over 1 plus I. So again, I have two fractions and I'm subtracting them, so I get a common denominator. My common denominator is 1 plus I, and my numerator is 1 plus I minus 1. So the 1, I've got a 1 and a minus 1 at the top, so I'm actually just left with I over 1 plus I. So if you want to pause, take that down, let's start again from the top. Now, even at this stage, we're still in a bit of trouble with our fractions. We have a fraction on the top and a fraction on the bottom. So obviously we need to try and get rid of that. So instead of dividing by I over 1 plus I can multiply by the reciprocal. So I can actually multiply by 1 plus I over I. Rather than dividing by this fraction, I can just flip it and multiply. So now, right, some of my fractions are gone. You should notice that you have a 1 plus I on the bottom and a 1 plus I on the top, which means that they're going to cancel each other out. So let's just write this a little bit simpler now. My top line is now a multiplied by 1 plus I to the power of t minus 1, and my bottom line is I multiplied by 1 plus I to the power of t. So you should recognize at this stage that we are getting fairly close to what we're trying to achieve. The next thing, let's continue further and try and get rid of our fractions even more. So to get rid of my fractions now, I can multiply both sides by I times 1 plus I to the power of t. So if I do that, if I multiply both sides by that, I'll get p times I times 1 plus I to the power of t, and on the right hand side my fraction will be gone. So I have a times 1 plus I to the power of t minus 1. And now all you have to recognize is that you're trying to isolate your a. So I just want to get a on its own. So what do I need to do to the right hand side to get a on its own? Well, clearly I'm just going to divide both sides by 1 plus I to the power of t minus 1. So if I divide both sides by this bracket, my top line is p times I times 1 plus I to the power of t divided by 1 plus I to the power of t minus 1. And so you can see yourself there, as we go through it, it works itself out. It looks very, very complicated when I'm here, but all of a sudden I get to exactly what I'm looking for. So I think the key to that question is make sure you understood what I did with the first frame in this video. Make sure you understand how I got my geometric series. There's a couple more examples of that in the rest of this question, so let's continue on and make sure we understand it. In the next part of this question, we're told that Alex has a credit card debt of €5,000 and that he repays it in equal monthly repayments, and that the value of each of these repayments is 2.5% of the original debt. So we're just asked to find the value of one of these repayments. So the original debt is €5,000 and the value of each repayment is 2.5% of that. So I just need to get 2.5% of €5,000 and my answer is €125. Okay, so for the next part of this question, we're told that the APR charged by the credit card company is 21.75%. Okay, so they charge 21.75% on all of the debts. But if you're given your interest rate as a percentage, the first thing you should always do is convert it to a decimal. So in other words, you divide it by 100, the APR is 0.2175. And I need to find the equivalent monthly interest rate to three significant figures. So just imagine if you started the year with €1 and you earned 21.75% interest. That means you would end the year with €1.2175. Or in other words, you'd earn that much interest on your €1. Okay? Now you'd have to ask yourself, what did you do to this €1 to get from here to here? Well, what I do to this €1 is I multiply by the interest rate. Okay? The interest rate we're concerned with is the monthly interest rate. So how many times did I earn the monthly interest rate on this €1 to convert €1 to this? Well, it took a year to get from here to here. So that means I earned the monthly interest rate 12 times. Now I'm going to represent the monthly interest rate as 1 plus I, where I represents the monthly interest rate. So I start the year with €1 and I'd end the year with €1.2175. But over the course of a year, I would earn the monthly interest rate 12 times. So now notice the question is to find the monthly interest rate. I've got one equation and only one unknown, which means I'm going to be able to find my I. So remember, if 1 plus I to the power 12 equals 1.2175, well, clearly I want to isolate my I. So that means rather than having all of this to the power of 12, that's the same as 1 plus I. You want all of this to the power of 1/12. So it's 1.2175 to the power of 1/12. So all I'm trying to do there is isolate my monthly interest rate. So if you plug all of this into your calculator, you'll get that 1 plus I is equal to 1.0165. Okay? Now clearly I want the I on its own. So if I subtract 1 from both sides, that means that the monthly interest rate to a decimal is 0.0165. But the question asked me to get the monthly interest rate as a percentage. So to get it as a percentage, I'm going to multiply by 100, which means that my monthly interest rate, if I multiply this by 100, is 1.65%. And that's the three significant figures. So again, always go back and make sure you leave it in the right form. So 1.65 is three significant figures, and I have it as a percentage. So the monthly interest rate, equivalent to a yearly interest rate of 21.75%, is 1.65%. Now for the next part of this question, it's very straightforward, but the wording on the question is incredibly hard to understand. Okay, so I'm told that Alex is now repaying the €5,000 debt. I know that the amount he repays each month is €125. So the fixed amount, he's going to repay €125 every month. I know that it starts off that he owes €5,000. And in the first month, his previous balance only reduces by $42.50. So I need to ask myself, why isn't it reducing by 125? Well, notice at the end of part 3, it says the APR is 21.75%. Now I've worked out that from part 2, an annual percentage rate of 21.75% is equivalent to a monthly interest rate of 1.65%. So you should notice that what they're doing in this question is the original. So in the first month, he owed €5,000. If you get 1.65% of €5,000, that is equivalent to €82.50. So that's the amount of interest that he has to pay in the first month. If the value of his repayment is €125, but he has to pay this much interest, well then that means he only actually reduces the balance by $42.50. So $82.50 and $42.50 is adds up to 125. So the balance only reduces by $42.50 which means 5,000 minus 4250 gives me this value. Okay, so if we continue this on now, for at the end, after the first repayment, I owe 4,957.50. If I get 1.65% of that, that means the following month I owe 81.80 in interest. And since I'm repaying a fixed amount every month, that means that I only reduce the previous balance by 43.20. Again, these two figures have to add up to 120. Then 43.20, if I subtract that from the previous balance, I'll get the new balance, which is 4914.30. Continue the process again. 1.65% of that is 81.09. If I subtract 81.09 from 125, I get 43.91. If I get my 43.91 and subtract it from my previous balance, I'll get the new balance. And the process continues. So again, in this question, just the wording on the question was very difficult. And to be honest, I think for a lot of people that year, it was literally just a matter of playing around with the figures and trying to come up with a figure that fit in here for the first one. Once you identified this was 82.50, the rest of the question, it's incredibly straightforward when you figure out what's going on. So I hope all of this made sense. Based on this question, just make sure you never get into credit card debt. You can see yourself, the majority of what Alex is paying is all just interest that's going to the credit card company. So credit cards are a bad idea, kids. Okay, so for B part 4 of this question, we're asked to work out how long is it going to take Alex to pay back his credit card debt of €5,000, based on the figures that we've already used for B part 1, 2, and 3. Now, there's two ways I could do this. So it says I could use the formula that I derived in part A, which is the amortization formula, or I could do it by using the sum of a geometric series. Now, I'm going to do this video by using the amortization formula. However, when you finish this, it's worth your while going back, see if you can do it by using the sum of a geometric series. So I know that A, the value of each repayment is €125. I know that the monthly interest rate is 0.0165. Now I'm using the monthly interest rate because he's repaying €125 every month. So that's why we're interested in the monthly interest rate. And notice that I'm using it as a decimal as opposed to a percentage. So the answer to B part 2 was 1.65%, but when I'm using it in a question, I need it as a decimal. So I need it as 0.0165. And P is the value of the debt, which is €5,000. So the only thing I don't know is T, or in other words, how long it's going to take him to repay this debt. So the first line here, all I've done is subbed into my amortization formula. Instead of A, I have 125. Instead of P, I have 5,000. Instead of I, I've got 0.0165. Now in the next line, all I've done is multiplied both sides by 1.0165 to the power T minus 1, which means it's 125 times 1.0165 to the power T minus 1. And on the right hand side, I've multiplied 5,000 by 0.0165. Now notice I can multiply 5,000 by that, but I can't then multiply that by 1.0165. I have to leave my 1.0165 on its own because it's to the power of an unknown. So just leave it as it is, there's nothing I can do with it. So this becomes 8250 times 1.0165 to the power T. Now on the next line, all I've done is multiplied everything. I've multiplied the 125. 125 by this is just 125 times my unknown. 125 by minus 1 is just minus 125. The next line, I brought all my t's to one side, all my numbers to the other side. So my 125 comes across and becomes a plus. My 8250 comes to this side and becomes a minus. At this stage now, on this line, I have 125 times this to the power t minus 8250 times this to the power t. So these are actually like terms. It's equivalent to if I had 125x minus 82.5x. I can just subtract them from each other. 125 minus 82.5 is 42.5 times 1.0165 to the power t. And that's equal to 125. So if I divide both sides by 4250, I now have 1.0165 to the power t equals 125 over 4250. Now at this point you should recognize that your unknown is in the power. If your unknown is in the power, the only way we're going to be able to solve this is to introduce logs. Okay, so once you recognize that your unknown is in the power, now we know we just have to introduce logs. So that literally just means you're sticking an ln in front of both sides. So ln 1.0165 to the power of t is equal to ln 125 over 42.5. Okay? The reason we introduce logs is because now we can apply the rules of logs. If you go to page 21 in your log tables, in the middle column we have our rules of logs. The third rule of logs is that if you have log of something to a power, you can just bring the power in front. So in this case, my left-hand side just becomes t times ln 1.0165. Now all of a sudden my unknown is no longer in the power. So all of a sudden this question has become a lot easier. So it's ln 125 over 42.5 on the right-hand side. Now if I want to get t on its own, I'm going to divide both sides by ln 1.0165. Which means my right-hand side will become ln 125 over 42.5. Make sure you put that in brackets. Divided by ln 1.0165. These are all numbers. So I can just plug them all straight into my calculator. And if you put it into your calculator, you should get 65.9. Now that means it's going to take 65.9 months for Alex to pay back his credit card debt. The question asked me to leave it to the nearest whole number or to the nearest month. So in this case, my t is going to be 66 months. If he pays €125 back each month and he pays 1.65% interest, it's going to take 66 months before the loan is paid off. Okay, so for B part 5 of this question, we're told that Alex takes out a €5,000 loan from the credit union in order to pay back his €5,000 to the credit card company. Now the reason he does this is clearly because the APR for the credit union is significantly lower than it was for the credit card company. It's 8.5% for the credit union, it was 21.75% for the credit card company. Again, if you're given the interest rate as a percentage, you divide by 100 and the figure we're actually concerned with is 0.085. Now there's two methods of doing this question. Where you want to work out how much is he going to have to pay back per week if he pays it back for 156 weeks. I can use the amortization formula or I can use the sum to a geometric series. Now in this video I'm going to do it by using the amortization formula, but I want you to go back and try it by the sum of a geometric series after you've watched this. Because there is scenarios where in the leave insert they could actually tell you which method to use. So you're not always going to have the option. In this case we have the option, but I think it's very likely you could be cornered. They could tell you to use the sum of a geometric series to find the value of each weekly repayment. But in this case I'm going to do it by using the amortization formula. If I use the amortization formula, I'm looking for A, so I'm looking for the value of the repayment. I know that P is 5,000 and I know that T is 156. My only concern is that I don't know what I is. I is the weekly interest rate. So if I know the annual interest rate, I can work out the weekly interest rate by doing exactly what I did in B part 2 of the question. So if I started the year with €1 and the APR is 8.5%, that means I would end the year with €1.085. Okay, now I'm going to introduce my weekly interest rate. So if I start the year with €1, I would earn the weekly interest rate 52 times. So it would be the weekly interest rate to the power of 52. Whatever I started with, multiplied by the interest rate, the weekly interest rate 52 times would give me €1.085. So now I just want to isolate my 1 plus I. So if I want to work out what the weekly interest rate is, the 1 plus I will be equal to 1.085 to the power of 1 over 52. So rather than having this side to the power of 52, I have the opposite side to its reciprocal, to the power of 1 over 52. Now if you plug that into your calculator, 1 plus I works out as 1.00157. Okay, so 1 plus I is 1.00157. Which means if I subtract 1 from both sides, my monthly interest rate as a decimal is 0.00157. Now that's the form that I wanted in. We've no reason to get it as a percentage. Unless in the question it asked me for the monthly interest rate as a percentage, I don't need it. So this is the form I'm going to use it in the amortization formula. So now I know what P is, I know what I is, and I know what T is. which means it's going to be relatively straightforward to work out what A is, where A represents the weekly repayment, the value of each weekly repayment. So let's just sub straight in here. A, which is each weekly repayment, is equal to P, which is 5,000, times I, which is 0.00157, times 1 plus I, which is 1.00157, to the power of T, where T is the number of repayments. In this case, the number of weekly repayments is 156. And I'm going to divide that by 1 plus I, which is 1.00157, to the power of 156 minus 1. We can just plug this all straight into our calculator, and since it's money, it makes sense to go to 2 decimal places. So that means that the value of each weekly repayment is going to be €36.16. Okay, so again, when you've done this, I now want you to try and do it by using the sum of a geometric series. So first of all, you want to write out what your geometric series is, and then sub into your formula for the sum of a geometric series, and try and find the value of each weekly repayment. Okay, so for the final part of this question, we have to work out how much money will Alex save by paying €5,000 back to the credit union, as opposed to paying €5,000 back to the credit card company. Well, clearly we have to work out how much is he going to pay each one. I've worked out that if he's paying it back to the credit card company, he's going to pay €125 per month. And if he does that, it's going to take him 66 months to pay back his loan. So if he pays the credit card company €125, 66 times, that means he's going to pay the credit card company €8,250. So of a €5,000 loan, he has to pay an extra €3,250 in interest. However, if he pays the credit union back, he's going to pay, we've worked out that he's going to pay €36.16 to the credit union 156 times. If he pays this much to them 156 times, that means the total amount he's going to pay them back is $5,640.96. So clearly, if I subtract these two values, that tells me how much money he saves by paying a loan back to the credit union as opposed to the credit card company. Again, because it's money, it makes sense to go to 2 decimal places. So in this case, that means he would save €2,609.04. Okay, so that's the amount of money he'd save if he took a loan out from the credit union as opposed to just paid back the credit card company. Okay, so again, I hope all of this video made sense. In a number of cases there where I used the amortization formula, I could have used the sum to a geometric series. So I want you to go back in the two cases where, in the case where I worked out the 66 months and the case where I worked out the 3616, make sure you know how to do those questions by using the sum to a geometric series. And as always, if there's anything you're unsure of here, just send me an email or let me know in class, and I'll come up with an alternative way of explaining this.